Hi there, today I'd like to talk about one of the most important design considerations that you have to factor in when you're looking at using dry running linear plane bearings. That's something we call the 2-to-1 rule. Simply put, the 2-to-1 rule takes into account the frictional characteristics of the bearing system as well as the bearing spacing of that bearing system. And from there, you get an idea of how far of a cantilevered load you can have, as well as how far you can drive the system without binding. So here in front of me, I have a drylin W system. This carriage is 100 millimeters long. That means there's basically 100 millimeters of bearing spacing on this system. What the 2-to-1 rule means is that you have to keep every acting force on that system within a 2-to-1 ratio of that 100 millimeter bearing spacing. So in this case, you want your payload as well as your drive force location to be within 200 millimeters or less in order for a proper system functionality. So let's talk about two very important aspects of the 2-to-1 rule. First, let's look at the drive force. You want to keep your drive force located as closely as possible to the bearing system. That makes it very low friction force, very easy to move. When you start moving up at closer to that 2-to-1 rule, there is more friction force to move the part. And right at about 2-to-1, you get to a point where it binds, it no longer moves. And how the 2-to-1 rule affects the center of gravity of your payload is that if you exceed the 2-to-1 ratio, you might see binding, chattering, or stiction in the application. So what do you do if you're outside of 2-to-1 with your drive force or your payload? The simplest thing to do is increase the distance between the bearings on the rail so that you accommodate for the 2-to-1 rule. Another possible solution, if your payload is outside of 2-to-1, you can look at adding a counterbalance on the opposite side to bring the center of gravity back in closer to the bearing set. This does add additional load, which means there is potential for higher wear in the long run. An example of another solution could be using one of Drylin's hybrid bearings. This combines a rolling and sliding system. Basically, you get to a 5-to-1 ratio, but these are strictly meant for hand-powered applications. All right, stay tuned for another important upcoming video about fixed and floating bearings that ties in directly with this 2-to-1 rule and will help you with all your linear bearing designs going forward. All right, so there you have it. There's the drylin 2-to-1 rule in a nutshell. For further information, we do have a tech talk available. You can access that by clicking the link below. Also, feel free if there's any questions to reach out to igus, www.igus.com, or give us a call. Thanks for watching. Have a great day.